Welcome to the Intel FPGA online training presentation, the eCPRI Intel FPGA IP Getting Started. My name is Marlon Price and I'll be the presenter. During this presentation, you may pause, stop, and start the training at any time. On the left side of the window, you'll find the outline section which allows you to skip forwards or backwards to specific slides. Please enable closed caption or click CC at the bottom of the player window if you'd like to follow along by reading a script of the course. This training is the first in a series of courses designed to help you become familiar with Intel FPGA's IP solution targeting the Enhanced Common Public Radio Interface or eCPRI protocol. By the end of this course, you'll be able to describe why FPGAs and the eCPRI Intel FPGA IP together make a good solution when implementing a fronthaul interface. You'll be able to describe how IP fits into a RAN solution targeting the FPGA. Finally, you'll be able to describe some of the specific features of the eCPRI Intel FPGA IP. The course will begin with an overview of the eCPRI IP. Then we'll look at some of the IP's key features. We will finish by looking at some of the other 5G IP from Intel FPGA complementary to the eCPRI IP. This training assumes that you have a good understanding of the eCPRI protocol, as we're not going to spend much time defining its details. The course assumes you're familiar with the Intel Quartus Prime Pro software tool suite and its design flow when targeting FPGAs. And while it's not absolutely necessary, a good understanding of Intel FPGA architecture is also helpful. If you have further questions on the 3GPP or eCPRI spec, here are some links to resources. This includes links to the eCPRI Intel FPGA IP user guide and the design example user guide. If you need to download and license the eCPRI IP, you can find information on this in the IP's user guide. So let's start with an overview of the eCPRI Intel FPGA IP. The eCPRI IP implements the eCPRI interface protocol used in fronthaul connections between the baseband unit and the remote radio head. Using the eCPRI packet-based methodology, additional bandwidth can be transported using fewer fibers in comparison to CPRI. To do this, the IP can support both eCPRI radio equipment control and eCPRI radio equipment, the two endpoints to an eCPRI link. Together, the eCPRI radio equipment control and eCPRI radio equipment comprise a single eCPRI node, so a system requires at least one of each. This is pictured in the block diagram at the bottom of the slide. The eCPRI Intel FPGA IP is compliant with version 2.0 of the eCPRI specification. It supports all three information flow types: user plane, synchronization plane, and C&M or control and maintenance plane. To create a more complete RAN solution, the eCPRI IP can be paired with the ORAN Intel FPGA IP, though a custom RAN IP may also be used. For the transport layer, the eCPRI IP has interfaces to connect to both soft and hardened versions of Intel's Ethernet IP in select devices. Being familiar with the 3GPP and eCPRI specs, these diagrams should look familiar to you. To review, the 5G 3GPP spec defines 8 major functional partitions or split options for implementing radio network functionality. Split 7 is then further subdivided into sub-options 7.1, 2, and 3. These splits allow designers to determine where they want to implement certain baseband processing, as different systems have different topology and system requirements. These diagrams here show a partial look at the functional splits, focusing on splits 6 through 8, with the 3GPP PHY on the left and matching it to the eCPRI 5 functional splits on the right. The splits also allow the designer to control the required interface bandwidth. These numbers here demonstrate some capacity examples resulting from a 236 gig bandwidth requirement at the radio head. In our example here, the highlighted area calls out the 7.2x splits specified by the O-RAN Alliance, where a 236 gig bandwidth requirement at split 8 drops to a 20 gig bandwidth requirement at split 7.2. The eCPRI Intel FPGA IP provides an excellent solution for your eCPRI needs. Pairing this IP with the FPGA's programmable fabric and its highly configurable high-speed transceivers, the FPGA provides a unique platform that supports various functional splits, interface standards, and upgradability. This table on the right highlights some of the RAN scenarios requiring programmability that benefit from the use of Intel FPGAs. For fronthaul interfaces, 4G uses split 8 and the eCPRI protocol, while 5G typically uses split 7.2, 3, and 4, supported by eCPRI, O-RAN, and radio over Ethernet. As designers try to support both standards using IP and equipment, both old and new, the need may arise to support different splits and different interfaces. Regarding fronthaul processing, devices may need differing PHY-layer functions to satisfy specific requirements. Using FPGAs means the functions such as compression or precoding can be moved into or from the FPGAs as needed with relative ease. Finally, on communication service providers deployment, vendors can exploit classic FPGA advantages to design their systems with post-deployment upgrades in mind, thus upgrading from 4G to 5G, changing fronthaul interfaces and functional splits, and modifying transport protocol features can be done with the same device and hardware and sometimes even in system. This diagram shows the eCPRI Intel FPGA IP and how it can connect to the other interface IP in a system. Here we see the O-RAN subsystem portion of an enhanced or next-generation node system. You have the eCPRI IP interfacing with the Ethernet MAC and PHYs on one side for access to the transport network, and the O-RAN IP on the other side in both the distributed and remote units. This table shows the Intel FPGA device and Ethernet IP solutions that are supported by the eCPRI IP. FPGA support includes Intel Agilex, Intel Stratix 10, and Intel Aria 10 FPGA families. For Intel Agilex FPGAs, the IP is currently supported on eTiles and F-Tile devices with the tile resources configured for 10 gig or 25 gig Ethernet operation. For Intel Stratix 10 devices, the IP is supported on FPGA variants with H and E tiles, again with 10 gig or 25 gig Ethernet operation. For Intel Aria 10 devices, all variants are supported with 10 gig E operation. Always refer to the user guide for the latest in device support information. The eCPRI IP also has support for interworking function or IWF type 0. This allows the IP core to serve as a bridge between an eCPRI network and eCPRI nodes, converting eCPRI message types 0, 2, 6, and 7 to eCPRI. The advantage is in bridging to older equipment that uses the eCPRI standard, eliminating the need for complete replacement. When IWF type 0 support is enabled, bridge logic is inserted between the eCPRI node and the eCPRI link, so that the eCPRI link sees an eCPRI connection when looking towards the node, but the eCPRI IP sees only a standard eCPRI interface. Now that you have a good high-level understanding of the eCPRI IP and its place in the system, let's look at some of its key features. The table on this slide and the next summarize some additional features of the eCPRI IP. The IP supports multiple Ethernet frame types, including source and destination MAC address frames and VLAN frames, along with IPv4, IPv6, and UDP. This includes jumbo frame support up to 9,000 bytes. There is support for up to 8 destination MAC addresses. Default addresses can be programmed when configuring the IP, but can be updated using the IP's programmable control and status register space. For packet processing, the IP contains logic to handle packet classification and routing on incoming packets, header removal for incoming packets, and header insertion for outgoing packets. The logic can also handle payload concatenation and deconcatenation, allowing 2 or more eCPRI messages to be combined into single Ethernet or IP UDP packets. These processes and flows are covered in the follow-up training to this one. The IP has a 16-entry packet queue for staging incoming packets for its arbitration logic. The arbitration rules are also covered in the follow-up training. For the CNN plane, there is an optional feature for Simple Network Management Protocol and Internet Control Management Protocol packet classification and filtering. For the synchronization plane, the IP has classification and filtering logic to perform eCPRI one-way delay measurement using the Precision Time Protocol, or PTP, logic in the corresponding Ethernet IP. The IP has resources to detect many types of transmission errors, including timeout errors. For quality of service, the IP can check for VLAN and stack VLAN tags and map tags to a vendor-specific eCPRI PCID. Finally, the IP uses pre-programmed priority logic to arbitrate the different packages, assigning priority first to PTP 1588 packets, then to eCPRI packets, and lastly to CNN packets. For our last section in this course, we quickly want to highlight the other IP available for 5G RAN solutions. Here are some of the additional 5G Intel FPGA IP that are available today. As mentioned before, Intel FPGA has an available O-RAN Intel FPGA IP core. It is supported on the same device families as the eCPRI IP. Then there's also the CPRI Intel FPGA IP. It is supported in many Intel FPGA devices, including the ones mentioned previously, and can connect to the eCPRI IP when IWF Type 0 is enabled. Lastly, there's the 5G LDPC Intel FPGA IP for encoding and decoding data streams in 5G wireless transmission channels. Use the links on this page to access documentation on these IP cores. This concludes our introductory look at the eCPRI Intel FPGA IP. In this training, you learned how Intel FPGAs and the eCPRI IP can make a good solution for your fronthaul interface requirements, how the eCPRI IP fits into a RAN solution along with other Intel FPGA IP, and some high-level features of the IP. Intel provides multiple avenues in which to learn about Intel FPGA products. There's the Intel FPGA YouTube channel, which contains 5-minute quick videos along with longer, more in-depth training videos. There's the Intel FPGA training website, where you can access e-learning courses made up of narrated slides presented in an interactive player, some courses even with labs and demos. Lastly, you can enroll in a live instructor-led course presented either in person at an office local to you or virtually over the web. All instructor-led courses have hands-on lab exercises to practice the concepts you learn. If you need more assistance, Intel FPGA provides many self-help resources for you to access. For example, there are web pages called landing pages dedicated to specific FPGA technology like external memory interfaces and high-speed protocol interfaces. You can also view and post questions to the community forum, which is monitored by skilled Intel FPGA applications engineers. The Intel FPGA training team is always looking to improve our material, and we welcome any feedback that you may have. Please email fpgatraining@intel.com with any of your thoughts or comments. This concludes the training. Again, my name is Marlon Price. Thank you for attending and have a good day.